In this section, we will talk about the hazards associated with hurricanes, including storm surge, damaging winds, tornadoes, and flooding. Historically, storm surge is the deadliest hazard associated with hurricanes. The very strong winds blowing on the ocean's surface creates an effect similar to a tidal wave on the leading edge of the storm. The stronger the winds, the higher the storm surge. As the hurricane crosses the coastline, so does the surge, and then it's simply a function of your elevation. Any structure on the Texas coast below 15 feet mean sea level is at serious risk from storm surge. Storm surge is created by the very strong winds of the storm blowing on the ocean surface. These winds create ocean currents some 200 to 300 feet deep below the storm. As the storm approaches land, the currents feel the impact of the continental shelf below. The water can no longer sink and recirculate back out to sea, and has nowhere to go but up and over the shallow barrier islands and into the bays and coastal waterways. It is the right front quadrant, with respect to its forward motion, that experiences the greatest impact from storm surge. The opposite side of the hurricane can also be affected, but typically at a significantly reduced value. In some cases, the water can be pushed out to sea by the strong winds blowing away from land. In addition, surge impacts on this opposite side can be felt on the backside of barrier islands. Let's take a look at some examples of storm surge. Hurricane Katrina produced a storm surge of 25 to 30 feet as it roared ashore into the Mississippi coastline in 2005. The damage left in the wake of this hurricane was incredible. Thousands of structures simply vanished from the scene by the powerful storm surge. Although Katrina was a powerful Category 5 storm over the open ocean, this hurricane had weakened to a Category 3 at landfall and did not come ashore at full force. Hurricane Rita is another hurricane that produced a devastating storm surge. This storm was also a powerful Category 5 over the open Gulf of Mexico, but weakened to a Category 3 at landfall over southeast Texas and Louisiana. Rita produced a surge of 15 to 18 feet, with the greatest damage observed near Holly Beach. However, the surge was observed as far east as Erath, some 80 miles to the east of where the center crossed the coastline. The surge also penetrated 30 miles inland to Lake Charles, inundating homes and businesses, including the casinos in the Lake Charles area. How high could the water get on the mid-Texas coast if a major hurricane struck? The National Weather Service has a storm surge model called SLOSH that can estimate the height of the storm surge in hurricanes. In a Category 3 storm, water levels could reach as high as 10 to 11 feet along the barrier islands and in and around Corpus Christi Bay as depicted on this image. How deep would the water be? You have to subtract your elevation to determine water depth. For example, in Port Aransas, the mean elevation of the community is 7 feet mean sea level. Assuming the right front quadrant of a Category 3 storm impacted Port Aransas directly, the water depth could approach 4 feet in the homes and businesses in that community. The accuracy of this data is plus or minus 20%. For a Category 4 hurricane, water levels could approach 14 feet along the barrier island and 15 to 17 feet in and around Corpus Christi Bay, Aransas Pass, and Rockport. This would be 3 feet over the seawall, protecting downtown Corpus Christi. We've never had a Category 5 hurricane hit Texas, and only 3 have ever hit the United States directly. Thus, it's a rare event. However, if it were to happen, the impact would be catastrophic for our community. Water levels could reach 17 feet on the barrier islands and 20 to 25 feet in and around Corpus Christi Bay, Aransas Pass, and Rockport. A direct hit from a Category 5 hurricane could extend beachfront property as far inland as Weber Road. The following scenario was produced by Dr. Gordon Wells from University of Texas in Austin for the State of Texas Emergency Management. They used the National Weather Service SLOSH storm surge model and GIS. In this example, a Category 3 hurricane will make landfall just south of Corpus Christi, placing the city in the dangerous right front quadrant. The following are flood inundation maps depicting the inland extent of storm surge if such an event were to occur. The first image is centered over downtown Corpus Christi and illustrates the flood inundation of a 14-foot storm surge. The next image is a different perspective of the same area. The next image is centered over the ship channel in the port of Corpus Christi. As we move up the coastline to Ingleside, Port Aransas, and Rockport, the surge values won't be quite as high with the storm making landfall to the south of Corpus Christi, but could still reach 11 feet mean sea level. The next image shows the potential flood inundation of Rockport and Fulton. Now let's talk about the winds of a hurricane. A hurricane's intensity is categorized by the wind speed. The maximum sustained winds in a Category 1 hurricane are in excess of 74 miles an hour. In a Category 5 storm, sustained winds can reach or exceed 155 miles per hour with higher gusts. It is the wind gusts in a hurricane that causes the most damage. In this photo from Hurricane Andrew, a Category 5 storm which struck South Miami in 1992, you can see the raw power of the hurricane force winds. Let's explore some wind facts. On average, a Category 4 hurricane produces 100 times more damage than a Category 1. And hurricane force winds are not just for coastal communities. Hurricane winds can extend as far as 150 miles inland from the coast. Thus, those who live inland and away from the water should make preparations to protect their properties as well. Here is a radar image of Hurricane Emily, a Category 3 storm as it made landfall in Mexico, 80 miles south of Brownsville. Note the size and shape of the eye wall and the outer extent of the tropical rain bands that extend into South Texas. Category 3 winds could be expected in the eye wall region, while winds gusting to 55 miles an hour were recorded 80 miles from the center over Brownsville, Texas. Now let's compare this with the eye wall of Hurricane Andrew, a Category 5. This is the radar depiction of Andrew's eye wall making landfall in South Miami. In the pink area illustrates wind gusts of 200 miles an hour. The wind damage from Andrew was incredible. In this image, the concrete high-rise structures are still standing. However, the windows are blown out, and the internal contents have suffered a total loss. This was Burger King headquarters, and the image on the bottom right was the CEO's office. The next photograph from the devastated areas of South Miami show a mobile home park. Now let's look at the well-built homes. Remember, Florida's building codes require homes to be built with concrete block. Overall, the structures are still intact. However, nearly every building has a hole in the roof, an opening in their window or doors. Once the wind penetrates through an opening, the internal structure often suffers a total loss. Tornadoes in tropical storms and hurricanes are primarily caused by the interaction between the spiraling winds of the storm and friction with land. Tornadoes primarily occur in the right front quadrant of the hurricane, either in the eye wall region or within the rain bands some 150 to 200 miles from the center. Tornadoes typically occur during daylight hours, when the heating from the sun makes the atmosphere more unstable and conducive for development. The individual tornadoes usually move very quickly as they are embedded in rain bands that are fast moving. This graphic illustrates the 10 largest hurricane-spawned tornado outbreaks. In Hurricane Ivan in 2004, nearly 130 tornadoes were documented. This beats the previous record of 115 set back in 1967 by Hurricane Beulah. This storm hit South Texas directly and also produced record flooding. In this radar image of Hurricane Ivan, the greatest number of tornadoes occurred in the rain bands far from the center of the storm. Here are a few of the tornadoes that were captured by photographers during Hurricane Ivan. During Hurricane Emily, which struck Mexico in 2005, a half a dozen tornadoes occurred in the coastal bend, some 150 miles north of the center. Heavy rains and flooding. The final hazard associated with tropical storms and hurricanes is heavy rains and flooding. On many occasions in South Texas history, a slow-moving tropical storm or hurricane dropped several feet of rain, producing devastating floods. In 1921, Hurricane Allison. In 1921, a hurricane produced 36 inches of rain in the hill country. And in 1954, Alice produced nearly 3 feet of rain near Del Rio. But in 1967, Beulah was the biggest rainmaker for the coastal bend with 2.5 feet of rainfall. 1978, Tropical Storm Amelia produced 42 inches in the hill country. And in 1979, Tropical Storm Claudette produced nearly 4 feet of rain in the community of Alvin, near Houston, and most of that occurred in a 24-hour period of time. 1998, Tropical Storm Charlie produced 18 inches of rain in 4 hours. And in 2001, Tropical Storm Allison meandered slowly over southeast Texas, dropping 2.5 feet of rainfall and resulting in $5 billion in flood damages.